Assalamu alaikum, dear students. From today, I'm starting solving MCQs as well, and we are starting from chapter number 2, Kinematics, 2002 and 2003 questions. Actually, these are complete papers, but I am just selecting questions from Kinematics, any chapter number 2. And of course, slowly and gradually, we will solve these MCQs as well. But the first part, the first question here, which is related to the kinematics, you can see here, the graph relates to the motion of a falling body. Which is a correct description of the graphs? Why the distance, why the distance, why the speed, why the speed? Here, first of all, you have to check that in this graph, we have two parameters. One is time, which is already given, but the other is y, which is not given, and they are asking what is y basically. So this is what actually mean of this correct description of the graph. Here we have to consider two very basic points. First of all, check this thing: motion of a falling body. Motion of a falling body. It means that if we are considering the distance, like here we have distance, y is the distance. So what is the first one? Why the distance and air is negligible? So here you can see that the graph is increasing with decreasing order, yani slowly and gradually the value is increasing with the you can say slope is decreasing. Rate of decrease means the slope is decreasing. It means that the velocity is decreasing, and you know that if you have a body which is falling towards the earth, then speed will always increase. So whether it's a air resistance is negligible or not negligible, you cannot consider these two options, because the gradient of this graph, if this is y, this y is distance, then the gradient of the graph will be velocity, and what this graph is showing, decrease in velocity. So this is not the situation here. Then if you are considering y as a speed and air resistance is negligible, so if the y is a speed and air resistance is negligible, then there should not be any decrease in the velocity. So this is again the same thing. This is not the correct option. So what is the correct option remaining, you can say, is the D, and this will be the correct option, because y, the speed and air resistance is not negligible. So when the air resistance is not negligible, you have a condition that the velocity is decreasing. So this is important, and you know that at this stage, you know the velocity, if you will consider this y as a speed or velocity, then the gradient will be the acceleration. And you know that what this graph is showing, that at one point the acceleration becomes 0 or constant value, yani slope is acceleration, and when the slope is 0, it means the acceleration is 0. And this will happen only when the air resistance will not negligible. And you can recall that at this stage the body will move with the terminal velocity. So somewhere here you can say that we have achieved terminal velocity. So this is what is the correct answer here, D. I hope this description is clear. Then as far as the question 7 is concerned, for our sequence, you can say it's a question number 2. Here we have question number 1. Here we have question number 2. In the paper, we have this question as question number 7. Which graph represents the motion of a car that is traveling along a straight road with uniformly increasing speed? Uniformly increasing speed. So again the same thing, you know that when you have a situation like acceleration is increasing, so it's not possible, it's not correct option. Here you can see that the displacement is increasing uniformly, so it means that the velocity is constant. Here they are saying increasing speed. So if the speed is constant, this is not the correct option. and here you have the distance, and in this case you can say and see that this straight line shows that we are dealing with the body which is at rest. So even this answer is not correct. So here this is the only situation remaining, and if you can say that these are not correct, then you can approach the correct answer. What you can say, increasing is uniformly increasing speed, yani the acceleration is constant. So this is very, very important. You know that when the speed is increasing uniformly, what is the increase in speed? This is acceleration. And you know that a is equal to v minus u divided by t. So if the for different time intervals, you can say that this change divided by time, if same, then the acceleration will constant. So this is the situation of the uniformly increasing speed, and that's why you can say that our correct choice will be A. I hope this is also clear, and the description is very important. Yani, normally students have this behavior that just hit and trial situation, but if you know that what is actually happening, then you will of course can select or choose the correct answer. Here we have question 8. For R sequence we can say it's a question 3, but whether it's 3 or 8 doesn't make any difference. Actually the question is, a stone is thrown upward from top of a cliff. Here suppose we can say that, like suppose here we have a situation. This is the height of the cliff you can consider here. You can make like this. So the cliff, after reaching its maximum height, yani you have thrown something from this point, and the maximum height is suppose somewhere here. It falls past the cliff top and into the sea. So from this point, suppose A is going to B, and from B it's not stopping back to the cliff top, but is going towards the C. So somewhere here you are, and this is, you can consider as C, not C, not this C, but letter C. The graph shows how the vertical velocity v of the stone varies with time t after being thrown upwards. R and S are the magnitudes of the areas of the two triangles. So what is the height of the cliff top above the sea? So this is very important, and you should know that when we are considering the velocity time graph, for velocity time graph, area under the curve is the displacement. So this is the main point you have to remember here. It means that when we are you can say throwing something, this is the point from where we are throwing. It's moving up. So at the highest point, somewhere here at B, the velocity becomes 0, and then it's coming back. Then from B, it's coming back towards the C, and suppose here you have this C. So when it will be here, this will be the point C, you can say. And here again the same thing. This distance from B to R is this distance R, and of course this the above distance is S. So if you want to know the height of the cliff top above the sea, so actually what you have to do, you have to find out basically this distance from point A to point C. So how you can get this thing? Simply R minus S, yani from this distance, when you will subtract this one, you will get this distance, which is the height of the cliff, you can say. So basically what you are subtracting from R, S. So this is the option here, and you can say that our correct option will be D. Be careful that R is the total height from, or total distance from B to C, which is not required. S is only this distance from the cliff to the highest point, which is not required. R plus S is of course nothing, because this is absolutely wrong. So only the right answer will be r minus s. So this is what we have in this case, which is your paper 2002 May June. Then we are going to this paper, which is 2002 winter 2002, October November 2002. Here a particle, this is our question here from kinematics. A particle is moving in a straight line with uniform acceleration. Uniform acceleration. Which graph represents the motion of the particle? So simple thing is that here this is this thing, when the body particle is moving, but here you can say and see that graph shows that the particle is at rest because there is no change in the displacement throughout the time. So you can simply neglect this question, answer, or you can reject this answer. Then here we have velocity b. B is showing you the velocity, but this velocity is constant. So uniform acceleration, no, this is simply a is equal to 0 situation, because the slope of the velocity time graph, as we have just discussed, slope of the velocity time graph will be the acceleration, and here you can see that there is no slope, so a is equal to 0. So this is not our option. We are going to the next one. C, you can see here that the slope of this curve or slope of this graph, which is velocity time graph, is constant, and this is nothing but the uniform acceleration, constant acceleration. So you can choose very simply the answer as C. Even you can see here that D is not correct because acceleration is increasing, and you know that we have not considered anything in which the acceleration is increasing. You have to be very careful, like v is equal to u plus at, or s is equal to ut plus half at square, or 2as is equal to v square minus u square. In all these equations, remember one thing, that the acceleration is constant. So this is a sort of condition for these you can say equations, that we are using these equations only for the constant acceleration. Any simple thing is that uniform acceleration is our limit of the syllabus, you can say. So D is not the correct answer here, and we can reject this D as well. So this is the answer simply of your paper winter 2002. Then we are going towards another question here, in which again you can see the graph, and this shows here that you are dealing with a body falls from rest in a vacuum near the Earth's surface. The variation with time t of its speed v is shown below. As you know that when there is no air resistance, so the velocity is increasing uniformly. Yani simply you can say that the acceleration is constant, which is g, where a graph shows the variation with time t of the speed of the same ball falling in air at the same place on earth. So when you are considering the situation with air, or the friction, air friction, if you are considering that, what will be the situation of the graph? So remember one thing, that what we can outrightly reject, like B we can reject, because here if you are dealing with the dashed line as the original line here, so never ever this can go up. Any graph cannot have anything like this, because this shows the more velocity. So in air there will not be any you can say increased velocity situation. Similarly here you can see that in part C, even this part shows the same velocity as here, but then you can see the velocity is increasing. So again, this is not the possible situation. Now what about A and D? In case of A, you can say and see that okay, the velocity after a time is decreasing. After a time the velocity is decreasing, but yani the rate of velocity decrease is decreasing, you can say. Of course the velocity is not decreasing as such, but the thing is that this part shows that for this much time the velocity is same as before, which is not the correct situation. So only the correct situation, possible situation is that when you will use the same situation here, the body falls from rest in vacuum, not in vacuum this time. Here you have the air. So what will happen? Of course, the initial velocity will be same as before, but very soon the velocity will increase, you can say decrease, or you can say the rate of velocity decreases. So this is very, very important, and this time will come very soon after just fall after few seconds. The velocity will increase but with the decreasing rate. So this is very important. Here you have the decreasing rate, here you have the decreasing rate, but in this case this part is a big part and this will not happen in case of air. So your choice will be D. So this is what we have as far as the question number 10 of your October November 2 is concerned. So here we have only 2 questions based on your kinematics. Then in question in paper 3 we are starting from May June 3, and here you have the question based on projectile motion. A projectile motion is fired, a projectile is fired at an angle alpha to the horizontal at a speed u as shown. So this is what you have. This is speed or velocity is given as u initial velocity. What will be the vertical and horizontal components of its velocity after time t? Assume that the air resistance is negligible, which is a basic condition of projectile motion, you can say. The acceleration of the free fall is g. So this is also another condition of the projectile motion. Here you have to recall that in case of projectile motion, what we can do or what we have been actually doing, that we can resolve this velocity into 2 components. One is uy and or uv you can write, any vertical component. Here you can say that this is ux or any horizontal component. As far as this uy is concerned, you know that this is u sine alpha and this is u cos alpha. So as far as this part is concerned, horizontal component u cos alpha, and you have to recall what we have studied, that in case of projectile motion, horizontal component always remains constant. So this is the basic, you can say, situation of the projectile motion when there is no air and the motion is under gravity. So it means that B and D outrightly we can reject, because here the horizontal component is something like this, which is wrong. Now if we are talking about the vertical component, so we have been studying that in case of projectile motion, what will happen? The situation will be like the horizontal component remains throughout the same, but the vertical component changes. And when you will be, you can say somewhere here moving towards the highest point, so even at the highest point, the horizontal component will be same as this one, but the vertical component is different. Yani over here, the vertical component changes and it becomes 0. But they are not talking about the highest point. They are just saying the velocity after time t. So what we can recall, equation v is equal to u minus gt, because we are you can say moving under gravity. So instead of v is equal to u plus at, we can write like this. Even we can say that we are dealing with vertical components. So vv is equal to uv minus gt. After time t, what will be the vv? So as you know that we have this component which is u sin theta, in this case alpha, and minus a gt. So again the same thing in the remaining two, A and C, you can see here that the velocity component, yani vertical component, will not remain constant throughout the motion. So this will be a wrong situation. This is right, but this is wrong. So A we can reject, so only C will be our answer. Because here you can say and see that u sine theta minus gt will be the vertical component after time t, and of course as we have just discussed that the horizontal component remain constant. So this is the situation vv. Here UH or VH, this is same. Yani initial or uh, after time t, the horizontal component will remain the same, but the vertical component will not. So vertical component cannot be u sine alpha, but it will be u sine alpha minus gt as we have just written here. So your correct answer will be C. Be careful of this description, and this is very, very important. Then we are moving towards another question. Here you have another graph. The graph of velocity against time for an object moving in a straight line is shown. Which of the following is the corresponding graph of the displacement against time? So basically, we have to consider which displacement time graph is giving us this velocity time graph. So you have to remember that the velocity is increasing, then up to this point is increasing, then it will constant, and then it's decreasing. So what you have to consider is where we have this graph. Here you can see that the displacement is increasing with the constant rate. So the velocity is constant throughout this point to this point. Then suppose this is your, say, point A, B, C and D. So here you have from point A to B, you can say and see that what is happening. The slope is increasing uniformly, any velocity is increasing uniformly, and of course the displacement is also increasing. But from point B to C, which is this area, the slope of displacement time graph is a constant slope. So slope of the displacement time graph is nothing but velocity. So simply you can say that the velocity is constant throughout. Then from C to D, you can say and see that the displacement is increasing, but is increasing with decreasing rate. And what was the rate? Again, the rate is velocity, but the decreasing rate means velocity is decreasing, and here we can say and see that the velocity is decreasing. So the corresponding graph to our given graph is nothing but this C. And here you can also check that what is happening here. The display, this part is nearly same as this one, but this part is nearly same as this one, but here the situation is different. You can say and see that the slope is constantly changing. So there is no you can say difference, any slope is constant here. So but in this case slope is constantly decreasing. So this is a different situation, and same is the case here. This is not the situation that it's just a constant and another constant. So this is absolutely wrong. Otherwise, if we will consider this part, then the velocity time graph will be something like this, that for this part we have constant velocity, then for this part we have another constant velocity, and then for this part we have another constant velocity. But of course this is not the situation given. So D is not right, A is not right, and even if you will consider this B, this displacement is constant. So of course the velocity is not increasing. So how we can say that B is a corresponding graph of the given graph, and same is the case for this part. So the velocity in both these graphs is zero, as the slope is zero. So in both these situations velocity is zero, but you know that velocity is not zero in our given graph. So even this B is not correct. So be careful of these situations. So this is our uh, uh, number question number 8 of your 2003 May June 2003. Then we have here another graph. Ninth, a ball is released from rest above a horizontal surface. The graph shows the variation with the time of its velocity. So velocity time graph is basically given. Areas x and y are equal. This is because, again the same thing, as soon as you will read this line areas, so you have to come quickly to the concept that you know that velocity time graph area is nothing but distance, as I have already told you, distance or displacement. So this is the basic point. The ball's acceleration, so you know that when we are talking about the areas x and y, there is no concept of acceleration, so you can outrightly reject this A. The speed at which the ball leaves the surface, again the same thing. We cannot talk about the speed. Here area is nothing but the displacement. So B is not right. Similarly, if you will go to the C, for one impact, the speed at which, so again the same thing, speed is not our concern, only the point which we can consider here, the ball rises and falls through the same distance. Why? Because as I said, this x and y areas are showing you the distance. So whenever you will read this, you have to come to the conclusion that we are actually considering, or our concern is the distance or displacement. So the ball rises and falls through the same distance. So remember this thing, that here you have the impact, after impact it will go up and move down. And basically you can say is a ball is released from rest. So basically from this is the point when you can say the point of release. So this graph shows that the velocity is increasing, but this is the point of impact. Yani, this is the point where the body will hit first time and then it bounces back. So these are the areas, not the acceleration. This is also only showing you the distance. So be careful, and this is your correct answer in this case, which is D. And this is your May June 3 kinematics questions. And then we can go to the October November, and here you have two questions related to our discussion, you can say the kinematics thing. In this case, again, here you have graphs. A car at rest in a traffic queue moves forward in a straight line and then comes to rest again. So what is the situation here? Distance time graph. So you can say that this is the distance where the body is at rest, then it moves, because the slope of the displacement is nothing but the velocity. So this is nothing but velocity or speed. So the graph shows the variation in the time t of its displacement. What is the speed while it is moving? So simple thing is that you have to find out the slope of this graph. So you can say that if we are considering this line or this point, to the corresponding point y-axis, you can say from y-axis we can get those. Here you have 70 and 30. So the distance and the you can say time will give you the speed. So v is equal to s2 minus s1 divided by t2 minus t1. So s2 is 70 and s1 is 30 divided by time t2 is 100 and time t1 is 50. So this is what you have here, 40 divided by 50, and when you will calculate this, simply you can get the 0.80. So simple, is very simple, but you have to recall the graph and the calculation, how you will do the calculation. Basically, if you will be perfect enough, then even you need not to calculate this thing here directly. By using your calculator you can get the answer. So this is very important. The answer is B. Of course, here as you are doing the calculation, so you need not to consider all other things, all other options, and simple thing is that B will be your option. Then we are going for question number 8 in 2003 October November. An object is dropped from a great height and falls through air of uniform density. Falling from a great height, drop from a great height. The acceleration of free fall is a g. The acceleration of free fall is g. Which graph could show the variation with time t of the acceleration a of the object? So simple thing is that here you can see that this is the basically they are giving you the acceleration time graph, but somewhere here you have the value g, which is basically telling you that a is equal to g, which is 9.8 meter per second square. Same is the case everywhere, but here you can say that the you can say you are starting from zero value, yani g is 0, which is not the correct answer. So first of all you can reject this D. In case of D, of course you are starting from zero value, which is not correct concept. Here in these three A, B, C, we can discuss that what is the situation of Z, C and B. You can say here particularly in C there is a decrease and then it becomes nearly constant. G is becoming constant. So this is not the situation when you are considering the G. What is the situation here? The acceleration is constantly decreasing because you are dropping the body from a height, great height. So of course what will here through the air, it means that this air will work and it will work against the weight of the body and you will have a concept of the terminal velocity. So it means that if you are going to attain the terminal velocity, acceleration g at this time will not be constant, but of course it will be something else we will discuss, but it's not constant. Same is the case, it is starting from 0. So as I said that in case of D you cannot start from 0, so this is also wrong. So only the right answer remaining, you can say answer or possibility is A. And this is logical as well, because when you are dealing with the drop of a body and the acceleration, then you know that the acceleration decreases because the resultant force will decreases. You know that when the body is starting falling, you can say that what is happening, weight is the only you can say force, but when you are considering the air resistance, so if we are considering here another force which is the air resistance, so I can write here Fr. So what will be the situation? Fr will increase with the speed and with the time, and at one point what will happen, the weight will become equal to the air resistance, which is this situation at W is equal to F air. So at this time there is no resultant force, and when there is no resultant force, so there is no acceleration or zero acceleration going towards the zero, you can say at least. So this is something which is important, and here you can say that the value of the acceleration is constantly decreasing, and of course at one point it becomes 0 as well, but they are not showing here this 0 part, but this is obvious that the acceleration is decreasing in this case. Why? Because the resultant force is decreasing. So this is what we have as far as the question number 8 is concerned, and this is the question, as I said, from your October November 3. So these are few questions which we have discussed today. Hopefully you have understood the discussion, and if you are new on this channel, you have to subscribe this channel to get more and more you can say uploaded videos, and these values inshallah will help you to understand and to get the concept clear. And if you will subscribe, then you have to press the bell icon as well. Share this discussion with your friends, and if you have any comments, you can contact me. The number, my mobile number is given in description, and I hope you are doing well. and keep working slowly and gradually, but if you will be consistent, then you can get a better grade. So till the next lecture, Allah Hafiz. My next lecture will be the theoretical part, and this will be on the chapter number 4, which is forces, and inshallah we will discuss the turning effects. And actually we have already discussed it, turning effect. This will be the continuation of the topic, and you know that after turning effect and couple of forces, we will discuss the equilibrium and conditions of equilibrium and other concepts. So you have to follow those lectures, and inshallah you will get better results. Till the next lecture, Allah Hafiz, take care.